course is about software comprehension and maintenance offered by Dr. Kamthan at Concordia University, winter 2016. In order to find some code smells and do refactoring methods, we have chosen a case study named a Freecol Game. What is maintenance? Maintenance is a part of the software development process, and it is prioritized based on software development model. For example, if we choose waterfall model, maintenance would be the last step in this model. And maintenance is intrinsically part of software evolution and aging. Refactoring is a part of the process of software maintenance. In this picture, you can see the software selection rationale. We have chosen our case study according to these factors. The first one is software attributes, which consists of line of code, documentation support to help us understand the code better, library support, source code availability, accessible source code repository. The platform is a Windows, programming language is Java, and between these two domains, game and software utilities, we have chosen Freecol, which is a strategy game. In this picture, you can see a snapshot of the environment of Freecol Game and some characteristics of this software, which is client-server strategy game. It's open source, Java-based, and 217,000 lines of code. In this picture, you can see our approach process. The first step we did is creating a GitHub repository because we worked as a team, so we had to manage the versions and synchronize our process. Then we upload Freecol Game and install Eclipse. Connect Freecol from repository to Eclipse. Install some tools for refactoring such as PMD, JDeodorant, Object8, and SonarQube. And we analyze and perform refactoring. For each refactoring, we created a separate branch. And after refactoring, we analyze it, test it, and after verifying and making sure that everything is okay, we merge the branch with the master branch. And as you see here, this is the process of our work. These are the branches for each refactoring, and this is the master branch here. The code smells we have identified is a God class. When a class gets bloated, the responsibilities and the functions in that class get less cohesive, so it's better to break it down into smaller classes with high cohesive responsibility. The other one is type checking. When too many cases in switch case or nested if-else instructions are existed in our code, this can be an example of a type checking code smell. Line methods, the methods which get so bloated that understanding and working with them gets very hard. Duplicated code. Duplication occurs when multiple programmers are working on different parts of the same program at the same time. And feature envy. This happens when an object uses the methods of another object to do something instead of using the object itself. So the first one is God class. One God class we found in this software is a player.java class, contains 226 methods and about 60 attributes and 4,270 line of code. So we should extract some related methods into a new class, which is player product in our case. As you see here, this is our new class, player product, and we have extracted some functions such as can see, reset can see tiles, and other functions which are related to each other, and we have put it in the new class. We have two kinds of line method conditionals, and we put both of them here to make a comparison between these two kinds of line methods. The first one is a readChild method located in the number results.java class. It has 55 line of code, which 35 of them are not cohesive to the method. As you see here, these are the unrelated codes which we have extracted them into another class, and we just put a reference to that method here. The second line method has been captured by JDeodorant as a line method conditional, but after analyzing the code, we found that it's not actually a line method. So this is a kind of a false positive result generated by this tool. And for type checking, also we have two kinds of type checking. One of them has been refactored using strategy pattern, and the other has been refactored by using inheritance and polymorphism. So here, as you can see in this picture, we have many cases. In each case, we have different instances of different classes and some implementation for that instances. So it's better to put the implementation in the main classes and just call those methods from that classes, which is kind of a dependency inversion principle also. So as you see here, we have a class and others as a strategy class or pattern, and others are inheriting this class, and we have an interface here. The second type checking, as you see here, has some nested if-else conditions, and there is a function copy form which has different implementations for each type. So it's better to use inheritance and polymorphism for this function. As you see here, we have defined copy form as an abstract function in tile_item.java, and the other classes are inheriting this class and implement this method differently. So this is a kind of polymorphism and inheritance used here. The next conditional type is feature envy. We also have two kinds of feature envy so that we can have a comparison between these two. One of them is increasing coupling, and one of them is decreasing the coupling between classes. In this picture, you can see a method, get no build reason method, which is using an instance of type buildable type, and also it's using many methods of this class. So actually we have a class, we have a method which its implementation is more interested in the methods defined in other classes. So it's an example of a feature envy conditional. So we can extract all this implementation to the buildable type class and just put a reference here to the function in buildable type class. Here you can see the class diagram of these classes before refactoring. Here we have an enumeration defined in colony class, and we have building type class with these functions, and after refactoring, a new function has been added here to the class buildable type, and the dependency between classes has been increased. So this is not a good refactoring because this class needs an enumeration type which is defined in this class here. So it increases the coupling between classes. The other example of feature envy is, as you can see in the picture, we have a class limit and operand. There are three functions defined in limit class which are more interested to the attributes of operand class. So we extract those methods from here and move them to the operand class. After refactoring, you can see that it has decreased the coupling between classes. So this is a good example of refactoring. And as you can see here, the operand class before refactoring and after refactoring, there are three functions added to this class after refactoring. And here we have another example of a feature envy. The same as before, we have an implementation in a class which is interested in a method of another class, means a player here. So we extract this code and add it to player class. But as we mentioned before, player class is a kind of God class. So adding more functionality to this class is not a good idea. And the last code smell is duplicated code. We have two classes here which are inheriting a superclass. These two classes have a function with the same implementation. So this is a kind of duplicated code. So to fix this kind of code smell, we can extract or remove those implementations from these two classes and put them in the superclass, and by inheriting these classes can use that method. We have computed two kinds of metrics on this software, instability metric and cyclomatic complexity. As you see here, we have chosen some packages which are the main, more important packages in the program, and using Object-Aid UML, we have generated the dependency between packages here. And according to these dependencies, we have calculated efferent, afferent, and instability metrics on these packages. And as you see here, we have many packages with instability 1, and the other packages have the instability close to 1. So more unstable packages lead to less reusability of the architecture of this software. The other metric is cyclomatic complexity. After computing, the complexity is 39 and risk assessment is high. The result is that source code has a very complex but manageable control flow. More efforts are needed for maintainability, and testing the program would be very difficult. At the end, we have some lessons learned. The first one, there are different code smells may exist in the source code of the software program. The smells affect on maintainability, understandability, and analyzability of the code. In order to fix code smells, we can use refactoring. For refactoring, different tools are existed. But tools may produce some false negative and false positive results. So we cannot rely on tools 100%. Results achieved by tools should be reviewed by humans. And refactoring methods suggested by tools don't always lead to a better situation in the code, as we discussed before. And here we have some links that you can use to test, and some questions in the Stack Overflow.